Alright, so today we're going to do Array-3, which is probably my favorite section on this site. So it has about 9 problems. It has 9 problems, and we will just get started. Alright, consider the leftmost and rightmost appearances of some value in an array. We'll say that the span is the number of elements between the two inclusive. A single value has a span of 1. Return the largest span found in the given array. Go ahead and pause and try this. So efficiency is not a priority, so don't worry if like, hey, this has a lot of loops and it's doing a lot of work. Don't worry about that. Basically, here's my strategy. I'm going to go loop through the array, and for each number in the array, I'm going to ask what is the span of this number in the entire array. And so the way, and so like I'll split that up, and I'll put that in a method. So I'll call it int span, which takes the array and takes a number, and I want to find the span of that number in the array. So to do that, I'm going to have to find the leftmost and rightmost occurrence. So the leftmost occurrence of something is the same as asking like what's the first index of that something. So I'm going to write an index of method for my array. So take nums, and it's going to take a number, and so it's going to take so it's going to return the leftmost occurrence of that number. So all I have to do is say for int I equals 0, I less than nums.length, I plus plus, and if I find the number, return I. And then otherwise return -1. And then to find the rightmost occurrence of something in an array, that's the same as asking what is the last index of that element in the array. So I'm going to go ahead and write that method. So I'm going to start at nums.length -1 and go down to 0, doing I minus. And that is how I'll do that. So the span of a number is just going to be the last index of that number minus the first index of that number plus 1, because we're doing inclusive, right? So like for example, let's say like the number only occurred once in the array, the span would be 1, right? But if I did last index of minus first index of, well, those two indices are the same, and so that would give me 0. So that's why you can see how we should add 1 to get the range inclusive. Okay, and now all I need to do is get the maximum span. So I'm going to set the max to 0 by default, and then for each number in the array, I'm going to say max equals the maximum of what its current value is and the span of that number in the array, and then I can just return max. So as you can see, even if helper methods you think maybe make the code a little longer, they make things a lot easier to think about. Like this code, like I don't feel like writing any one method in this code was complicated. And sure, it's a lot of code. It's like one of the most code, or like this is some of the most code we've written for a problem so far. But splitting it up into helper methods just made it really easy to think about. And so that's what I did here, and it works just fine. So yeah, that is how you could do that one. Return an array that contains exactly the same numbers as the given array, but rearranged so that every 3 is immediately followed by a 4. Do not move the 3's, but every other number may move. The array contains the same number of 3's and 4's. Every 3 has a number after it that is not a 3, and a 3 appears in the array before any 4. Go ahead and pause the video and try this. Okay, so let's do this one. So here's my strategy. This is a pretty complicated one, I'll admit. It's one of the hardest ones we've done so far. So here's going to be my strategy. I'm going to have one index that is going to, I'll call it the 4 index, sure. It'll be going through the array, and it'll help me find where the 4's are. And what I'm going to do with the 4's is I'm going to swap them with whatever value is after a 3. So basically I'm going to have two indices going on. One's going to be tracking the 4's, helping me find 4's to put after 3's. And then the other index is going to be the 3 index. And it's just going to be looping through the array, finding 3's. And every time I find a 3, of course, I'll swap it with a 4. And the 4 index will help me find where the next 4 is that I could swap with it. So let's go ahead and write that. So I'll call the 4 index 4. Actually, what should I say? I'll call it swap index actually, swap index, and I'll set it equal to 0 for now. And then what I'll do is, actually, let's see. I want to set it equal to the first 4 in the array. So, because I want it to be whenever I find a 3, swap index should hold the next 4 that I need to swap into place. And so that's my plan. Whenever I find a 3, I'm going to use swap index is going to hold the 4 that I should swap into place after the 3. So by default, it needs to start on a 4. Swap index needs to start on a 4. So what I'm going to do is I'm actually going to just copy that index of method because, well, it's a fine method. Why not? Why not use it, right? So I'm just going to copy this method. And so my for index, or my swap index, is going to just start at the location of the first 4 in the array. Now I know the array contains the same numbers of 3s and 4s, and so if it does not contain any 4s, then swap index will be -1. And so therefore, I think I can just return the original array unchanged, because if it doesn't contain any 3s or 4s, then I don't really need to do anything. Okay, so now I'm ready to go. Gonna loop through the array and try and find some 3s. Okay, so I'm going to go up to the length -1. It says every 3 has a number after it that is not a 3, which therefore means that a 3 cannot occur at the end of the array. Okay, so basically if this number is a 3, then I need to do some swapping. So, okay, so I'm going to swap whatever's currently at the swap index, which I know is a 4. I'm going to swap it with the number after I. So I'll say temp equals nums I plus 1. The number after I gets, well, 4. I can, since I know it's going to be 4, I can just set it equal to 4, or I can say nums swap index, and then nums swap index equals temp. So yeah, I could replace this part with 4 if I really wanted to. Yeah, and let's see. If I do it in this order, I don't even need the temp. So if I do it in this order, yeah, we'll be fine because I know what swap index is. I know that num swap index is going to be 4 when I enter this if statement. Okay, so that's good. But now I need to move up swap index. So now it holds the next 4 in my array. And so I'm actually going to modify my index of method to take another parameter, and it's going to be the start index to consider. So basically, instead of starting I at 0, I'm going to start it at start. And I'll just pass 0 up here because, right, I want to start at 0 for the first thing. And now this will make things a lot easier because in order to update swap index so it stores the index of the next 4, all I need to do is say swap index equals index of 4 in the array, but starting at swap index plus 1. So starting after where I currently am, where's the next 4. And then I just need to return nums when I'm done. So that is how we could do this one. Yeah, so there are of course plenty of other ways to do that. I wonder if I've ever said that before. Hey. But yeah, that's how I'll go ahead and do this one. Okay, so this is a slightly harder version of the fix 34 problem. Return an array that contains exactly the same numbers as the given array, but rearrange so that every 4 is immediately followed by a 5. Do not move the 4s, but every other number may move. The array contains the same number of 4s and 5s, and every 4 has a number after it that is not a 4. In this version, 5s may appear anywhere in the original array. Go ahead and pause and try this. Okay, so I actually think our fix 34 code will work, like unchanged. Obviously, we'll have to change, because this is 4s and 5s and that was 3s and 4s. But otherwise, I think it still works just fine. There's nothing we need to really do. So I'll see. Like maybe I'm missing something, but I think it will just work. So fix 45, and this should be a 5 here. This should be a 4. This should be a 5. This should be a 5. Let's see. Yeah. Okay, and so I think that'll work. Okay, no it won't. Okay, so I am missing something. So if you have a case like this, that's still a 9. So interesting. So let's see here. Oh, because oh, that's right, because when whenever let's see, okay. So whenever when I'm moving fives around, now like the location of where the next five is might change when I swap some things around. So yeah, so here I let's see, actually, hmm, um, yeah, okay, I see. Sorry, I'm just trying to think of how we could do this. So, so I want to find the index of the next five, but so basically what's happening here is if you look at this first example, first thing I'm doing is I'm swapping this 5 and this 9. So it goes 9, 4, 5. But then I'm asking where's the next 5, and the next 5 is now right here. And so I'm reusing the same 5 and it's like doesn't know what to do. So it actually swaps that with that 5 again and then just like, or actually, no, it just overwrites it and I end up with something that doesn't make any sense. And just even worse stuff happens later. So I'm trying to think how to do this. Let's see here. Okay. Okay. So what we could do, here's what we could do, um, is, well, first let me see. So a 5 can be after a 4 already. Like just as we're past the array. A 5 can already be right after a 4, so it doesn't need to move, which is fine. I don't think that's going to be a problem. But here's what I'm going to do instead. It's kind of like a totally different solution, totally different strategy here. Um, so I'm going to delete index of because I don't think I need it. And here's going to be my strategy instead. Um, what I'm going to do is I'm going to find where all the fives are. And I'm going to basically store all of them, all the fives in an array. Um, and then like store all the indices of where all the fives are in an array. And and basically what I can do is, oh, actually, sorry, I'm just having a bunch of ideas. You're getting to see like live thinking. I know it's very exciting. I know me being silent and thinking. Um, okay, but what I can do is because like as I swap fives around, right? The indices of the fives are changing, right? As I swap the fives around. So what if instead of like so what if I make a copy of nums and then when I'm looking for like the indices of the next five, I just pass the copy so that the five locations never change in the copy. So like I'm only modifying nums, I'm not modifying the copy. So that way the indices never change as a result of me swapping things around. I'm going to try that. I think that'll work. I'll call it copy equals arrays. So if you want to copy something, you can do copy of range. And in fact, actually, let me check the API real quick. Um, arrays copy of, I believe is a method. Yeah, okay. So if you want to copy an array, you can just do copy of nums and pass the length of the nums array. I don't know why they make you pass the length here. I don't know why they don't have like a copy of method that just takes the array by itself. But this will let us copy the array, copy nums. And so what I'll do is instead of passing nums here, I'll pass copy here. Okay, that almost works. Okay, what's going on here? Um, oh, I see, because, oh, okay. Okay, so we have a 5 here, and then this 5 tries to get swapped with this 5, and then, but then this 4 needs a 5 after it, so then the next 5 that is encountered is this one, and so then this one gets swapped over here, and we end up with this. It doesn't make any sense. Okay, so how could we do this better? Let's see. What I could do is I could, I'm just like really exploring here, trying some things out. What I could do instead is I can make it so that in my copy, I take out all these fives. Like I set them to like some other number, like 0, in my copy, so that they're ignored by the index of thing here. And then also make sure to, in my main loop, also ignore cases where the next number is already a 5. So like if numSi is a 4 and the next one, numSi plus 1, is not a 5. Only then will I go in here, and what I'll do in my copy is I'll go through my copy, and I'll see if I ever find a 5 that's immediately preceded by a 4, I'll set that 5 to a 0. So I less than nums.length I plus plus if I find that I have a 5 followed by a 4, or preceded by a 4, then set that 5 to a 0. Okay, what have I done? Let's see. Okay, so what's going on here? Array index out of bounds exception line 11. Because you can't find any more 5s? That's, okay, so that's because of, okay. What's going on here? So in my copy, all of those are being set to 0. So what's happening here? So that's the first 5 that it should find. And, why? Okay, so if this first one, if we're going through and, let's see. If numSi equals 5 and numSi minus 1 equals 4, set it to 0. So we do the index of, and we find that the index of the first 5 is that. Then, okay. So we're going through, we should encounter this 5, and then we should swap it with what's there. I'm very confused. I'm actually going to go over to an IDE and try and work this one out. So let's go to Array-3. Sorry, I have to set some things up here. Oops, not that. I have to set some things up so we can actually do stuff. Okay, there we are. Okay, so let me add these methods in. Okay, all the indenting is weird because CodingBat. But okay, so I have this here. Okay, and so this is not working how I want it to for this, and I want to see why. So I'm going to print out this here. Oh my goodness. Fix 45 that. No, sorry, we need to make it in an int array. Okay. So this is doing that, which I'm not really sure I understand why. So what I'll do is I'll say, oh my goodness. Oh, the indentation's all messed up. It's annoying me. If I do this, it'll do what I want it. Okay, nope, that was not helpful. Okay, there we go. Okay, now indentation is good. Sorry, that just annoys the heck out of me. Okay, so, sorry, so oh my goodness. So I found, I'll, print out I here. Okay, so why is my question? Because I thought I'm explicitly checking that nums_i equals 4 and nums_i plus 1 is not equal to that. So is nums, like what is nums? That's my question. Because nums, like I feel like I shouldn't be doing that. Raise that toString nums. And nums is what? Oh, I'm not messing with the copy. Oh no. Y'all probably saw that and were mad at me. Okay, that's probably what it is. Okay. I should be modifying the copy here. Okay, and then 45415. What's wrong here? Okay, so I found it in x2, and and then print out. Oh my, sorry. I have a keyboard shortcut that's supposed to work, but sometimes it doesn't. Okay, so and the swap index is swap index here. Swap index is 1. Okay, so like you consider not being 1 swap index. Oh, because oh my goodness. All right, so this is what I get for making a copy. Okay, so I need to pass the copy there. Okay, well, that was something. Um, yeah, so yeah, well, I'm at a loss for words. So this is obviously one way to do it, but I don't like this way. Like I just don't. Um, I'm gonna try another way. You can obviously skip ahead. You have the chapters. You can skip ahead if you don't want to see the other solution. But I'm gonna go ahead and try another one. So, oh, and my headphones are out of battery, so they're making noises. Okay, so let's try another way to do this. Man, okay, so here is what I'm thinking. What I'm thinking is I just go through and I just okay, so here's what I do. I find whatever the number in the array that's not a 4 or 5, because we talked about how there can only be one number in the array that cannot be a 4 or 5 because order doesn't like it said all the other numbers, every other number can move. So therefore every other number must be the same if their order doesn't matter. And so what I can do here is what I'm going to do is I'm going to find what that other number is. So int other, I'm going to say for int in colon nums if if in does not equal 4 and in does not equal 5, other equals in. And then okay, so and basically I know that if there is no other number, that um, the array must already be good, um, because it says I can't move the 4s, and therefore if I can't move the 4s, then I could only move the 5s, and if I could only move the 5s, I could only swap them with other 5s, which means the 5s are already in place. So if other is I'll set it equal to -1 by default. Or actually, I'll set it equal to 4. There we go. I'll set it equal to 4 by default, because I know it shouldn't be 4. And then if other still equals 4, that means there was no other number. So I'm just going to return nums. Okay. So we found out what the other number is. So now all I'm going to do is I'm going to go through the array, and I'm going to set everything that's not a 4 to that other number. Length I++, if nums_i is not a 4, it's going to equal the other number. And then what I'm going to do is I'm going to go through the array once again, and then I'm going to say, stop one short of the end and say, okay, now if you have a 4, set the next number to a 5, and then return nums. Question mark? Okay, so yeah, that'll do it too. Um, so basically, all I'm doing is just saying, okay, just put a 5 in after every 4. Like, don't even bother swapping anything, just put a 5 in after every 4. And then make sure all the other numbers are just the other number, and then you're good. That's basically my strategy here. The reason I have to do this is because, like, the reason I go through and set all the 5s to others, to the other number, is because, like, some of the 5s might already be in place, and then if I try to set, like, if I just go through and set, like, put a 5 after every 4, then I might be creating more 5s than were in the original array, and that'd be bad. Okay, so I feel like I've done like a better job. I can live with this. This is not as just messy as the previous one. Okay. Given a non-empty array, return true if there is a place to split the array so that the sum of the numbers on one side is equal to the sum of the numbers on the other side. Pause and try this one. Alright, so what I'm going to do is I'm going to write a method, believe it or not, that is going to, oh, and by the way, place to split the array. Does that mean like a cursor position? Like I could draw a line between two numbers and then split by that? I think that is what it means. Yeah, that is what it means. Okay. So I'm going to write a method that's going to, it's going to be like a substring method, and that it takes like two parameters, two int parameters that define a range, and then it's going to sum the numbers in that range. So I'll just call it int sum. It'll take the nums array and then start index and end index, and it's going to say, it's going to create a sum variable and say for each number in that range, so I equals start, I less than end, I plus plus, and then it's going to add the number here to the sum. Okay, and now you can probably already see how we're going to do this. I'm just going to loop through all the possible positions I could split the array and get the sum on each side. So I'm going to say for int I equals 0, I less than, I'm actually going to say less than or equal to nums.length, so this will be as if like I split the array, but like at the very end so that all the numbers are on the left side. And I'm just going to say if the sum from 0 to I equals the sum from I to nums.length, then return true. Otherwise, false. Okay, so there we go. All right, two arrays of ints sorted in increasing order. They're called outer and inner. We need to return true if all of the numbers in inner appear in outer. The best solution makes only a single linear pass of both arrays, taking advantage of the fact that both are already in sorted order. So if you want to try and do this in your solution, I will be. But if you want to, you can. But if you don't want to worry about this, what this sentence is talking about, just don't worry about it. Just do it any old way you want to. Okay, go ahead and pause and try it. Okay, so first I'll show you what's just like the most obvious, the most intuitive, simple way of doing this. And I think that way is to just loop through every character in every character in inner and see does it appear in outer. So yeah, true if all the numbers in inner appear in outer. So I'm just going to make a contains method. There's unfortunately no built-in contains method for arrays. So I'm going to take my array and say int x, and I'm going to determine if the nums array contains x, which you know how to do. If in is x, we have found it. Otherwise, we have not found it. Okay, so what I'm going to do is I'm going to say for each number in inner, if it's not contained in outer, then we need to return false. Otherwise, they are all contained in outer, and we can return true. Okay, sorry. What am I doing? Did I read the directions wrong? I think I did. If all the numbers in inner appear in outer. Oh, I did this wrong. Okay, that would be good. Okay, there we go. Okay, so that's a very, I think, intuitive way to do it. Just literally does every number in inner, is every number in inner contained in outer. So here's a different way to do it that does what it was talking about, taking advantage of the fact that they're both in sorted order, because our code that I just wrote clearly didn't do that. So here's what we could do there. So if we're going through, we can see that, let's say the first number in inner is 2. I can loop through outer, so outer is the first one. I can loop through outer until I find a number, and basically until I find a 2. And if I find a number that's bigger than 2 without finding a 2, then I know that 2 is not contained in outer, right? Because I know that if let's say I made it up to a 3, I was looping through outer and I found a 3 without finding a 2, then I know that there must not be a 2, because if there were a 2, that 2 would appear earlier because the array is sorted in increasing order. So um, basically I'll loop through outer until I find a 2. Let's say I do find a 2. Obviously if I don't, like if I get to a number greater than 2 without finding a 2, I'll just return false because I know all the numbers in inner are not contained in outer. So let's say I do find a 2. Then I just go to the next number in inner, and then I keep looping through outer, but I start at where I left off. So I start after this 2 and then keep going. And then I would go to the next number and start where I left off, and over and over. So that's how I would do this. So I'll actually create 2 variables. I'll have O index, this is going to be outer index, and I'll have inner index. And actually, inner index will just be I in my for loop, so actually that'll be fine. I less than inner dot length, I plus plus. Okay. So the outer index is going to start out at 0. And what I'm going to do is I'm going to say, okay, so I'm going to look through outer until I find a number that is either equal to or greater than the current number in inner. So what I'm going to say is while while the outer number at outer index is less than the inner number at inner's index, then just increase the outer index. Keep looking through the outer array to find this number, to find inner at I. And then, okay, so now we keep looping. We found the number, and I say, well, first of all, while outer is less than outer.length. And then what I say is, well, first of all, if we went out of bounds of outer, if we search through everything in outer and we've not found it, then so if O index equals outer.length, then we just return false because we do not have everything we need. But otherwise, we look at the number here and we say, if the number at O index is equal to inner I, then we're good. We just continue. But if it's not equal to inner I, then we've went past it. We've gone past the number without finding it, so we can return false. And then if we're done, we return true. And let's see, is less than inner I. So sorry, it should be while O index there. And there we go. That's how we could solve this here. We could combine these if we wanted to as well. So there you go. And that's a nice way to do it. And this is more efficient. This code is more efficient. I'm not going to talk about efficiency really, but I'll just tell you that this is more efficient than what we had before. Okay. Given in greater than 0, greater than or equal to 0, create an array of length n squared with the following pattern shown here for n equals 3. You can see the pattern, so go ahead and try this one on your own. Okay, let's do it. So int array r is going to be a new int array with n squared elements. Then all I need to do is I'm gonna loop through the array, basically in at a time. I'm gonna go through in at a time. So I'm gonna say for int I equals 0, I less than r.length, and then I'm gonna go through in at a time. So I plus equals n. Okay, and then what I'm gonna do is I'm gonna go through the numbers in numbers from 1 up to n, and I'm going to and actually wait, I can I'm going to start I at index n minus 1, and I'll talk about why in just a second. But basically, I'm going to start adding in the numbers going backwards from I. So I'm going to go for int I'll also call it j, for int j equals 1, j less than or equal to m, and in my current iteration, let's see, because I'll keep a counter on the outside, which is the max number I'm going up to. So for starters, I'll just go up to 1, right? I'll go up to 1, and then I go up to 2, and then I go up to 3, etc. So I'm going to go up to the max, and I'm just going to say r at I minus j plus 1 equals equals j. And then I'll increment the max by 1. And I think that will work. We'll see. On line 5, okay. Max j plus plus. Okay, doesn't work for 0. Yeah, okay, so if in 0, return a empty array. It's probably fine. Okay, so that's how we could do this one. Now, there are, of course, other ways to do this. I'll show you one other way to do it. So I'll actually just, yeah, I'll comment just all of this out. So I'll show you one other way to do it. It's similar, though. So one way to do it would be to instead of, so to basically have an I here. So I'll actually call this number, no, I'll call it I still. So I'll call this number, yeah, I'll call this number I, and it'll go up to n. Yeah, it'll go up to n, and it'll just increment by 1 each time. And then what I'll do is I'll create a number k, and k is going to be the number, the first index in the pattern I'm creating. So like in like the current like slice I'm creating. So like the 1, it would be here, and then here, and then here. In this array, k would go from here to here to here. It's the index of the next 1 that I'm placing, basically. So I'm going to do I plus 1 times n minus 1, I think is what I need to do in order to do that. So like the first one, yeah, I think that's what I need to do. And then I'll just go for j equals 1, and then I can actually do j less than k because k now is going to align exactly with max. That's my whole idea here. And then what I can do is I can just say k minus j minus 1 equals k. Then I don't need to increment max. Okay, let's see what the heck I'm doing. Okay. Oh, okay, so so j doesn't go up to k, j goes up to I plus 1 here. Okay, that's better. There we go. Yeah, so this is an alternative way to do it. And in fact, since I'm only using k here, I could inline it, although at this point it is just getting real messy. And so it looks like I'm subtracting 1 and adding 1, so I could actually just do this. And then, yeah, so that is another way of doing this and trimming some things up here. It's actually quite concise. Do I need that if now? I don't. So, okay, so this is another way of doing it that is a bit more concise. So, yeah, let's go ahead and move to the next one. All right, so create an array with that pattern. You can look at the pattern. Go ahead and pause and try this. All right, so I kind of wish they didn't give you that hint that the size is going to be n times n plus 1 over 2. But that is an important thing to know in comp sci. Okay, so doing this will be, I think, pretty straightforward. So the array is going to be a new array. I did tell you to pause and do it right. Go ahead and do that if I didn't. Okay, so the array is going to be n times n plus 1 over 2. Okay, and now what I'll do is I'll have a so I'll have a counter on the outside. I'll have one variable on the outside. I'll call it, let's just do j again. And it'll start at 1. And what I'll do is, yeah, so j will be like the number I'm counting up to. So I'll count up to 1 first, and then I'll count up to 2, then I'll count up to 3, then I'll count up to 4, etc. So I'll go through my array, just every spot in R. and then I'm going to say for int, and then I'll do another variable. I'll call this max. Actually, I think that's a better name. So for j equals 0, sorry, j equals 1, j less than or equal to max, j plus plus. And I'm just going to say, let's see, I'm going to say r at index I equals j. And I also need to increment I here. And I think I actually don't need to do it here. So I can just do this instead. And then return my array, return r. Okay, no, it's because I'm not incrementing, I'm never incrementing max. Okay, there we go. That's how we could do that. One quick note is that I can, so I want to increment j and I at the end of every time of this internal loop. So you can actually, if you want to increment multiple things, you can just put a comma here and put it over there too. So you can have multiple things right there, which is kind of interesting. So I could do that. And actually, what I could do is I could put this right here as well. So there you go. And that's how we could do this one. This is so this is one way to do this problem here. Okay. We will say that a mirror section in an array is a group of contiguous elements such that somewhere in the array, the same group appears in reverse order. For example, the largest mirror section in 1, 2, 3, 8, 9, 3, 2, 1 is length 3, the 1, 2, 3 part. Return the size of the largest mirror section found in the given array. Okay, go ahead and pause and try this one. This one's a doozy. All right, let's do it. Okay, so here's going to be my strategy. There are plenty of ways to do this, but here's going to be my strategy. I'm going to go through. I'm going to have one pointer, one index. Sorry, I guess I shouldn't use the word pointer. One index that's going to be going through the array. And actually, let me draw this out because it's going to be quite a complicated thing we're doing here. So 1, 2, 3, 8, 9, 3, 2, 1, 9. Let's space them out a bit. 8, 9, 3, 2, 1. Okay, so here's my array. What I'm going to do is I'm going to have a bunch of indexes going on here. So one's going to be here. And then the other, so for each orange one, for each time the orange goes up, I'm going to have nested within that loop. I'm going to have one going up, one going that's going to, or one other index that's going to go, starting from over here, and it's going to go and look at the last number in the array. And what it's going to do is it's going to say, okay, if orange and blue are equal right now, then, well, basically, okay, first, I know I'm just getting complicated. Well, first we're going to make a second pointer, a second red one, right underneath this orange one here. And then what I'm going to say is, okay, if red and blue are equal, then move them closer. And in this case, they are. So I'm going to move them closer. So red's going to go there, and blue's going to go here. Sorry, here. And then I'm going to ask, okay, are red and blue equal? Yes? Okay, move them closer again. So then blue goes here, and red goes here. And then ask, okay, are red and blue equal? Yes, so move them towards each other again. So red goes here, and blue goes here. And then you ask, okay, are red and blue equal? No. Okay, so stop moving red and blue, and then count up how many times you moved. So in this case, we moved 1, 2, 3 steps to get from where orange is to where red is. Okay. So therefore, we found a sequence of length 3 that appears in reverse somewhere else. Okay, and then we move up. And so we keep track of that. We say, okay, longest one I've found so far is length 3. It's this one and this, right? So then I say, okay, move this orange thing up. Let me put the 3 back. Okay, so yeah, and let me draw that better. Okay, so then we go to the next one. We put a blue guy down here at the end of the array once again. And we make a red guy too. And we say, okay, are red and blue equal? If the answer is no, then move blue closer. Don't move red, but move blue closer. Okay. And then you ask, are red and blue equal? Yes. Okay, so move them closer. So sorry. So move them both closer to each other. So red comes here, and blue comes here. Okay, are red and blue equal? Yes, so move them closer. Blue is here, red is here. Are red and blue equal? No, so stop and count how much you moved red. So you moved it 2 hops to get from red to orange. So we now just found a sequence of length 2. Now length 2 is less than what our best, so we don't care. Okay, so then we move up orange once again. Now orange is here, and I am going to walk through the entire algorithm. Okay, so then you put the blue one back here, and put the red one here, and then you say, okay, are red and blue equal? No, so move blue forward. Yeah, and actually, let's see. In the first case, when I first ran out of when like red was here and blue was here, then when I first ran out, what I should have done is actually moved red back to the start, but kept blue in place. So blue would keep going down. Okay, so if okay, I'm starting with 3, put the red there, put the blue there. Okay, are they equal? No. So move blue down. Are they equal? No. Move blue down. Are they equal? Yes. So we need to move them both closer. So we move a red right here, and a red right here, and a blue right here. Okay. So, okay, and then we ask, are they equal? No. So put red back over here. And then, well, first, I guess, note that we've now found a sequence of length 1, but that's not very interesting. We found a sequence of length 1 that was just 3. And compare that to our best. It's not better than our best, so we don't care. And then say, okay, move red back, right? Whenever they stop being equal, move red back. And move blue down again. And then compare them. Okay, are red and blue equal? No, so move blue down. Okay, and now they're just pointing at the same spot. So of course they're equal. We found a clump of length 1. Compare that to our best. It's not better than our best. And so we're just done because they're equal. Okay, and then we move orange up again. We say, okay, there's orange. There's red. There's blue. Okay, so are they equal? No, so move blue down. Are they equal? No, so move blue down. Are they equal? No. Are they equal? No. Are they equal? Yes. So we've found a group of length 1. Not very interesting though. Okay, and now red and blue are equal, so we're done. Okay, and now we put the orange cursor there, drop a red one here, drop a blue one here. Okay, are red and blue equal? No. They're not equal there. They're not equal there. So then blue comes here. We found a clump of length 1, and then red and blue are at the same spot, so we are done. Okay, and then put this guy here. Okay, so are red and blue, I guess I'll use this color, red and blue equal? No. So move blue down 1. Okay, are red and blue equal? No. Okay, are red and blue equal? Yes, and they're at the same spot. We're done. Okay, and then move orange up. And then you say, okay, blue here, red here. Okay, are red and blue equal? No. So move blue up, or move blue down, I mean, move it closer. Okay, and then they're equal. We have a clump of length 1. Compare that to our best. It's not better than our best. And then red and blue are at the same spot, so we're done. Okay, and then you put orange one here. We put a blue one at the end. We put a red one where orange is. They're all in the same spot. We found a clump of length 1. Compare that to our best. It's not better. Blue and red are at the same spot, so we're done. And then orange has reached the end, so we are done with the overall algorithm, and 3 is our result. So, a lot going on there. We're going to code that. If you want to pause and think about why does that work, please do so. Okay, so I'm honestly actually just going to use the colors I was just talking about, um, because I think now that you've already got them associated in your mind, I think it'll just be easier if I do that. So I'm going to say int orange is going to start at 0, and then I'm just going to create red and blue. I'm going to assign to them when I need them, so I don't really care yet. Okay, and then I'm going to go through. I'm going to say, okay, for, and actually orange can just be declared inside the for loop, so because orange will just be looping up one at a time. So orange equals 0, orange less than nums dot length, orange plus plus. Okay, and then here's what I'll do. So I'll say, okay, so blue equals nums dot length minus 1, red equals orange. Okay, so basically I'm going to say while, so notice how blue basically moves closer every time. So like, blue moves closer every time. So we can just keep like looping it down. So we can say while blue is, let's see, while blue is greater than orange. So because we stop once blue makes it all the way to orange. So while blue is greater than orange, um, just keep going. And I don't know if we want to say greater than or equal to yet, but we'll see. Okay, so while blue is greater than orange, what we do is we say, okay, if nums red equals nums blue, so if the numbers there are equal, then what we do is we move them closer together. So we say red plus plus and blue minus minus. And then otherwise basically we reset red back to the start. We say red equals orange. And then before we move red back to the start, we know that we've now found a clump because we're moving red back to its start. So we say our maximum clump we found is 0. I'm just calling them a clump. They called it like a mirror section, whatever. Okay, so we say, okay, so the distance we've gone is red minus orange. So I'm going to say max equals red minus orange, and then I have to add 1 because, right, if they were at the same spot, we would have found a clump of length 1. Or actually, no. Yeah, we don't want to subtract them because red is at the first index that is not equal to nums blue. So we don't want to do that. We just want to subtract them without adding 1, and then red gets set back to orange. And yeah, so, and basically we're going to be decrementing blue every time, so I'm just going to put this out here. Okay, and then we're going to go through and keep comparing to the max, and then we need to return the max. Now I might be missing something here. Yeah, maybe, just maybe. Okay, so if nums red equals nums blue, increment red, and then decrement blue. Okay, let's see here. So really, okay, so I need to think why this isn't working for the first one, because it definitely should be doing so for the first one, right? We'll see. Let me go over to an IDE here, and we can debug this. So let's go ahead and do this. So we want to do maxMirror an int array containing these numbers here. And if I run this, I'll get 0. Okay, and then I say, okay, so I'm going to print out when orange. And so I'm going to use some interesting like print stuff that I haven't talked about, but just don't worry about it. You'll see what from the output what it does. So orange equals this. Okay, so we go through, we loop through all the oranges. And then, by the way, I'm going to format it here. Okay, so we go through everything here. And let's see, so then orange equals that, and then we say, well, blue is greater than orange. So I'm going to print out blue here. So blue equals %d. Okay, and then, so blue starts out as 7. And then whenever they're not equal, I'm going to print out that they're not equal. So not equal. And then when they are equal, I'm going to print out equal. So equal. And I'll run this. And I'm actually going to put the console on the side here because Oh no, get out of here. Minimize this. Okay, so let's see. So we go through here and we find that they're equal, equal, equal. So red plus plus. And then they're not equal. So okay, so when we first hit they're not equal, what's red equal to? So red. So red equals 3, yeah. And so max equals, oh, because max, hey, max should equal math.max, max of what its current value is in red minus orange. That's what we need to be doing. Okay. That is a bit better. Okay. Let's see, that might not be my only, my only bug, but let's try it. Oops. Sorry. There we go. Okay, and then what's happening here? So we have this situation. So what I think we want to do is, let's see here. Let's try it on this input because this input's not working. Okay, so we can do this, run it here. Okay, so orange equals 0. They're not equal. Okay, and then they're equal, they're equal. Okay, and I'm going to keep track of what the max is every time I enter. Because the max should be 3. So what I'm going to do is I think after my while loop, I also need to do the, because red might have a value, like a useful value after the while loop. And so I need to check that. So I'll say max equals the maximum value of max in red minus orange here. Because just because blue made it to orange and we're done there doesn't mean that we weren't working on a clump when that happened. Okay, so that's good. Well, now let's see. Okay, so so this should be returning 3. And so I'm interested, why is it not returning 3? So red equals, so I'll print out red when they're equal as well. Red equals that. Okay, so they're equal, red equals 0, red equals 1. And then, let's see, so what is red equal on the outside? So red outside. Outside equals red. Okay, so red on the outside equals 2 here. And so here, I think we want to include the, want to do a +1. The only thing is, like, I'm trying to articulate why that is because I don't think I fully understand. Let me just try this here. Try adding in this line here. Okay, so, so it works. I'm actually not entirely sure why. Let me think about that and see if I can articulate it. So, okay, so in here, the reason, let's think, why are we not adding 1 here? So the reason we're not adding 1 is because, let's see, is because here, okay, so here we know at this line where my cursor is, we know that is red is 1 more than the last element that was in the clump. So the real last element in the clump is at red minus 1, at index red minus 1. Right? So that's why we don't have to add 1 here, because red is already 1 more than where the real end of the clump is. But down here, red is not there. Red is well, actually, let's see. So yeah, so red is not, sorry, red actually is at the end of the clump. So up here, red was 1 more than the end of the clump, And down here, red was at the actual end of the clump. And so I need to add that one back. Okay, so that's why it's a bit different. Yeah, I'm trying to think if there's anything here. Yeah, because if we were doing the pointers for like this one, not the pointers, the indexes, the colors for this one. So it would go red here is blue here, red here is blue there, and then we go red and blue are both here, and then it would go blue here and red here. And then we'd see that, yeah, that okay, red, like the loop would stop, but red would be here, and they're equal. And so actually, wait, I think a better solution that actually is more accurate is to do this and then not have the +1 here. So that we are actually going up to and including, the actual orange spot there. So does this work for all things? I'm curious. Because if it does, I think it's better. Okay, so this is actually the good solution. What I had before, I think it fails for some cases that aren't tested here. I wish I could like think of a certain case, but I feel like it fails. I'm sorry, I know I'm not doing a very good job of articulating things. Okay, but this one now we know, and in fact, do I even need this line here? I'm trying to see, okay. Yeah, I do, okay. Because red might still have a useful value after there. Okay, but now blue goes all the way up and we include when blue is equal to orange. We still include that. And so now I know, okay, there might be a clump that like in the reverse direction it ended at orange and that's still fine. That's still considered a clump that like started at orange. So, okay, so that's how we could do this one. Yeah, that was not easy. It was not easy. Even when I came at you already with like a pretty good algorithm, yeah, it was not easy. All right, and of course there are other ways to do this. One way is to like try every possible contiguous subsequence of the array and then compare it to every possible other contiguous subsequence in the array and see if they're reverses of each other and then determine the max from that. That's super inefficient. I think it'd still be fine on CodingBat because CodingBat doesn't really care about efficiency. But what I have here, this actually is efficient. So yeah, what I have here is much more efficient than that. So all right, yeah, quite a difficult one, but a fun one too. Okay, so say that a clump, this one actually is about clumps, hey. We'll say that a clump that in an array is a series of two or more adjacent elements of the same value. Return the number of clumps in the given array. Pause and try this one. All right, so let's see here. Okay, so we want to count these clumps here. So I'll make a count variable here, and okay, so count equals 0. So what I'm gonna do, let's see, what should I do? So I'll go through here, and I'll say, okay, if I start, so I have to have two or more adjacent elements. So I'll loop through, and I'll say, okay, if I'm at an index, and well, first of all, if I'm at the start, like I'm gonna start a new clump here. What I check is whenever I get to an index, I check, okay, is the next number the same as me? If so, then I know that I'm part of a clump. And so if this is if this like what I just reached, the index I just reached is different than the thing before it, I know I've started a new clump. And so I'm going to increase my clump count by 1. And then when I go to the next index, I'm going to say, okay, is this the same as what I was just looking at? Yes, then I'm part of the same clump, so I'm not going to do anything. I'm not going to increase the clump count or anything. Then I'm going to go to the next one. Okay, so then I ask, okay, is this different than the number before me? And the answer is yes. So I might be starting a new clump. But I also check, okay, am I the same as the next number too? And I'm not. So therefore, this is not the start of a new clump. Then I look at the next number and I say, okay, am I different than the number before me? Yes. So I might be starting a new clump. And then I ask, okay, am I the same as the number next to me? The answer is also yes. So therefore, I am starting a new clump. And then I go to the next number and I say, okay, am I different than the number before me? No, so I'm not starting a new clump. I'm just part of a clump, and so I don't care. And I just move on. So that's what I'm going to do here. I'm going to go through my array. Nums.length I++. And so, first of all, if I is 0, so, well, first of all, I'll check if I'm different than the number before me. So, if I'm different than the number before me, or I'm at the start of the array. So if I equals 0, or nums I is different than the number before it. Okay, so if that is true, so if I'm different than the number before me, and the next number is the same as me, so for the next number to be the same as me, there has to be a next number, so n is not nums.length minus 1, and the next number, and I'm equal to the next number, so nums I equals nums I plus 1. Then I'm going to be starting a new clump. So count plus plus, and then I return the count. I does not equal. Okay, so there we go. That's how we could do this one. All right, so yeah, basically I'm just trying to find all the indices that start a new clump. And that's what this if statement basically does. It determines if the index I starts a new clump. All right, so that one, only 9 problems, but it took us over an hour. So, you know, these ones are getting difficult. I think Array-3 is probably also the hardest section in this, which is probably why it's my favorite, because, you know, these are fun little problems here. Okay, but yeah, that's all. We have, what, 7 sections left. Yeah, and these two are the 2 long ones that we have left, AP1 and Recursion 1, which are the next 2 episodes. So that is all for this video. I'll see you next time for AP1. Goodbye.